Okay, today we will be talking about the strain gauge lab. This is going to be your cantilever beam setup where your strain gauge is right here. This is going to be a quarter bridge strain gauge, and then your force bridge is down over here. This dial you can use to adjust the weight, so as you spin it down, more force will be applied to one end of the beam, causing the strain to change. And then we're going to be using Signal Express to find our strain and force. There should be a Signal Express already set up for you to use, but in case there isn't, I'll go through step by step of how to add the steps. You'll click on Signal Express and you'll wait for it to load. You'll do start with an empty project, click finish, and we'll make this full screen. And then we're going to want to go up top and click add step, acquire signals, DAC MX acquire, analog input, then you'll want to select the strain, and then it's going to ask what channel you're in. So you'll go over to your strain gauge, follow the wire from the strain gauge all the way down to your box, and we see that this one is in channel 0. So we'll click A0, and then it will load the strain setup like this. And then we can add another step over here, and we're going to want to look for the force, the bridge selection, because we're using a force bridge. And the same thing, we're going to look at our force bridge and follow our wire all the way down to our lab National Instruments box and see that it's in channel 2. So then we'll go up here and select channel 2. If you don't select your channels right, it won't give you any accurate readings. So then we're going to want to go to our settings. We'll start with the force bridge. This you can all leave the same. There's no reason that you have to change any of this. But you will go to device, bridge calibration, and then you're going to want to make sure that there is no force on this beam, or else your calibration is going to be off. Then you'll click next. You'll let it load, and then click calibrate. So now we have a 0% error, and we see that our measured value is -1.1 to the -3rd. So we know that our force reading is really close to 0, so we'll accept that. Next, we're going to want to go to our strain setup. There are a couple different settings on here that you have to change. Your TA should give you the values for each one. And then remember, this M isn't for meters. This M stands for milli. Same if you see a U, that's going to stand for micro, and then if you see like an N, that will stand for nano. So like I said, for our strain gauge, it is a quarter bridge setup. And then we'll do the same steps of calibrating here. And then we'll calibrate. And then just to be safe, we'll calibrate one more time. All right, so even though that our percent error is really high, we see that our measured strain is really, really low, like as close to 0 as we were possibly going to get. So we can still accept this. The other thing you want to check is to make sure that you're doing continuous samples. So you'll see it right here where it says continuous samples. Then once you're done calibrating everything, you can hide this bar, and it's going to show you a graph like this. But if you change it to a table, it'll show you some values like this. So this channel 0 was our strain, and channel 2 was our force. We'll click run to get some values, and it'll take a second. Then once we start to get some values, we can look here. So like I said before, this is reading 1.2 micro strain, and then this is -290 millipounds. So these are really small numbers, but it is important for your calculations to make sure that you're recognizing that this is micro and not just strain. Then we'll go over here and we'll turn this dial, and we want to get some readings between 1 pound and 2 pounds. So we're gonna have to play with this a little bit. It is a little finicky. So now we just shot up to like 13 pounds of force. So we'll back it off a little bit. Let it load, and we'll keep going. We don't have to get the exact numbers right now, but it is important to know that this will be your force reading that you get, and this one will be your strain reading that you get. Now you're gonna have like a table where you're going from a pound to 2 pounds, and then from 2 pounds back down to 1 pound, and you'll record those values. You want your pound reading to be really close. Like if you're trying to get to a pound, you're going to want it to be like 1.11 pounds. So once you get all your data from LabVIEW, you're going to create a graph of the stress versus strain, and you're going to have this linear line right here. You won't have this fracture curve right here, but one of the ways you can find your Young's modulus is to just find the slope of this line. There's another way to do it, but you'll need to go into the lecture slides to look that over. You'll also need to make sure that you're finding your results within a confidence interval as well. I always suggest doing 75 or 90%. Once you do that, you'll have everything that you need for your lab report, and then you just finish everything up. Make sure you show a nice graph with labels on either side, again with both ways you found your Young's modulus, and then you're done.